Hello, learners. Welcome to Edge Blush Virtual Academy. Welcome, grade 10. Thank you so much for joining us in our presentation, Physical Science. And your presenter is Mr. Sylvester. We are looking at electric circuit, and in my previous presentation, I've tried to explain how an electric circuit works, and I've explained that an electric circuit has got different components, and these components they work together. They allow the flow of current, right? And I also highlighted that whenever we deal with an electric circuit, we need what we call a power supply, and a power supply is in the form of a battery. It is acting like the pump which pushes charge right around the electric circuit, and Uh, we also have other components like an ammeter, which is always connected in series. And an ammeter is an instrument that we use to measure the amount of current that flows through a particular pathway, right? And I also highlighted that an ammeter has got very minimum resistance. Therefore, it allows current to flow through, and that's why it is also connected in series. We also have got another component like a voltmeter. I wish to explain a little bit deeper when it comes to a voltmeter. A voltmeter in an electric circuit, especially in grid 10, we always connect our voltmeter across the battery or the power supply and also across our resistors. And you must take note that a voltmeter is always connected parallel or across a component. It is never connected in series because a voltmeter is an instrument or a component of an electric circuit that has got very high resistance. And if you connect it in series, it is going to block the flow of current. And a voltmeter must be connected between 2 points so that it can measure the potential difference between those 2 points. If it is connected across the battery, it measures the potential difference between the positive and the negative terminal of the power supply or of the battery. So a voltmeter is always connected across, and it has got very high resistance. And then another component that is very crucial that I wish to remind you of, it is a switch. A switch is responsible for turning on and off the electric circuit. Remember, when the switch is open, no current can flow, and when the switch is closed, that's when current can flow. So in this presentation, I'm going to take you through very interesting lesson, a very interesting aspect, which is a series circuit. So I'm going to write here series circuit. Right. Remember, we have got two types of electric circuit that we look at. We have what we call a series circuit and a parallel circuit. Right. So what is a series circuit? This is what I'm going to draw, and then I'm going to explain what a series circuit is and how do we approach different questions when it comes to a series circuit. So as usual, for us to have a functional electric circuit, we need the power supply, which is in the form of a battery. A battery is a combination of many cells. Like in this case, we have got three cells there, which are connected together, and they form a battery, right? So we need a power supply all the time for us to have a functional electric circuit. In other words, a battery works like the heart. It is the heart of the electric circuit. It pumps charge right around the electric circuit. Right. So that is my electric circuit, and I've got my ammeter there. Allow me to call this a T, right? It is connected in series as usual, and it measures the total current of the circuit. And then there I've got my first resistor, and my first resistor is 5 ohm, right? We all know the unit for resistance is measured in ohms. And then I've got my second resistor there, uh, which is 3 ohm. And then I've got my final resistor. I'm going to deal with three resistors only in this presentation, and that is 4 ohm, right? And then I've got my switch there, and my switch is closed, which means current can flow. Then I have got another ammeter there. Can I call this one A1? Right. And then I've got my voltmeter here across the 5 ohm, and I call this V1, and another voltmeter across the 3 ohm, can I call it V2, and another voltmeter across the 4 ohm, and I call this voltmeter number 3. Then I've got also the VT, which is across the power supply. That is a series circuit. Now, how do I know that it's a series circuit? All right. There are few basics that we need to highlight that can assist us as we proceed, as we move forward with our electric circuits. Now, number one, when we say an electric circuit is a series circuit, we look at the way the resistors are connected. Let me be very particular with you because you are just grade 10. This is very important for you to note. Normally, we use the resistors. We look at the way the resistors are connected. If the resistors are connected one after the other or in series, like what we can see in this particular electric circuit, we call this a series circuit. Yes, we do have cases where you are going to deal with electric circuits and they don't put resistors, they put bulbs. You use the same principle. Look at the way the bulbs are connected. If they are connected in series or one after the other in one pathway, then that is a series circuit. Now, what is very important for us to appreciate is when we deal with a series circuit, these components, they must be connected in one pathway, that is in series, so that at the end we must always confirm that in a series circuit there is only one pathway for the flow of current through all the components. So in other words, when we deal with a series circuit, the only component that will be connected across will be a voltmeter, but the rest of the components are connected in series and there is only one pathway. I think we need to underline that principle, that concept, so that it makes our life easy. So let me label the resistors. The 5 ohm, I want to call it R1. Then the 3 ohm, R2, and the 4 ohm, I'm calling it R3. So this is a series circuit, friends. Our resistors are connected in series or one after the other, right? So there are three uh, basics that we need to explain under a series circuit. Number one, it has to do with current. The second one, it has to do with potential difference. And the last point has to do with resistance. Now, let's look at current. How does current move in a series circuit? So, bullet number one, it talks about current. So, when we are dealing with a series circuit, we must always appreciate that current is constant, or the current strength is the same at all points. I think it is more clearer to us. So the current strength, right? The current strength is the same, right? The current strength is the same at all points, at all points. That is only in a series circuit. So in other words, what it means is if you can put an ammeter, remember an ammeter is the instrument that is used to measure current. Wherever you connect an ammeter, the readings must be the same. So the current strength is the same at all points. You must also appreciate, friends, that we don't lose current in an electric circuit. So the total amount of current in an electric circuit is constant. It can only change when we have tampered with our resistance or when we have tampered with the power supply. But otherwise, if we don't tamper with the resistance, we don't tamper with the power supply, the total amount of current in an electric circuit is constant. So when we are dealing with a series circuit, you must know that the current strength is the same at all points. Right. Another point I wish to highlight is we look at what we call conventional current. Now, conventional current flows from the positive terminal of the battery to the negative terminal. So if I am to indicate the flow of current in this electric circuit, just look at the way I am putting the arrow there. That will be the direction of the flow of current. So all the current will flow via AT. So AT, that's ammeter, which is going to measure the total current. Current flows past that. Current cannot flow via V1 if you are looking at the electric circuit now, because all the voltmeters, they've got very high resistance. So all the current will flow past through 5 ohm, 3 ohm, 4 ohm via A1 back to the power supply. So in other words, wherever you can put an ammeter, the reading is going to be the same. So the current strength is the same. Is that okay? So the current that flows through 5 ohm, the current that flows through 3 ohm, and the current that flows through 4 ohm, it is the same. So the current strength is the same at all points. So in other words, if I am to look at the readings of AT and A1, I can safely conclude to say IT, which is the total current, right, is going to be the same as I1 because this is a series circuit. Right. Let's move on to the next item, which is potential difference. Now, when we are dealing with a series circuit, potential difference divides. This is very important. Potential difference divides. Now, potential difference divides evenly, right? So, in other words, what this means is our VT, if you are looking at the electric circuit now, which is the voltmeter across the power supply, our VT is going to be divided into V1 and V2 and V3. So in other words, if you sum up the reading of voltmeter 1 and the voltmeter reading number 2 and the voltmeter reading number 3, you put the three voltmeter readings together, they must give you back your VT, which is the terminal potential difference, because in a series circuit, potential difference divides. So this is very simple and this is very straightforward. Now let me try to preempt the topic a little bit and try to explain some other facts that we need to equip ourselves with. Allow me to divide that side. Now, if I am to calculate V1 reading, we use what we call the Ohm's law. And the Ohm's law gives us a formula which says V is equals to IR, whereby V is the potential difference, I is current, and R is resistance. So if I am to calculate V1, I am going to use the current that passes through that pathway, which in this case is the total current, because this is a series circuit. And the resistance that I use is not the total resistance of the circuit. I only use the resistance where V1 is connected. And we call that corresponding values. Right. So V1, if I am to calculate V1 using the formula V is equals to IR, the current that I use there is the current that passes through the 5 ohm resistor. And the resistance that I use is the resistance where the V1 voltmeter is connected. So in other words, V is equal to IR. Is that okay? If I am to calculate V2, I use the total current, which is the current that passes through the 3 ohm. So the current is going to be the same here because this is a series circuit. But the resistance, I no longer use 5. Neither do I use the total resistance. I use 3 across where V2 is connected. Then V3, the same story. V is equals to IR. Your current is the total current. Your resistance is going to be 4. So if you add up V1, V2, V3, that should give you what we call our total or our terminal potential difference, which is VT, right? And then that's it on potential difference. It divides equally or evenly, not equally, but it divides evenly depending on the resistance across where the voltmeter is connected, right? The last effect that we need to highlight is resistance. What about resistance? What happens to resistance when you are dealing with a series circuit? We must appreciate that resistance, right, increases. Resistance increases with an increase, right? Resistance increases in with an increase in number of resistors, right? So what it means is when we are dealing with a series circuit, whenever we add a resistor in series, the total resistance of the circuit increases. Right. I want you to listen very carefully, friends. So, if we want to increase the resistance of an electric circuit, just add another resistor in series. Then the total resistance increases. If you want to decrease resistance, the opposite is true. Remove a resistor in series, then the resistance decreases. Right. Another thing I want to explain, friends, is the relationship between current and resistance. You must always bear in mind that current and resistance are inversely proportional. I think I need to highlight that somewhere. Um, yes, I think I need to put a bracket and say current is inversely proportional to resistance, with resistance as the independent variable and current as the dependent variable. In other words, we change resistance and we measure current. So it is resistance which determines the amount of current. And you must also bear this one at the back of your mind that current favors a pathway that has got lower resistance. So in other words, when the resistance is low, the current becomes high. When the resistance is high, current becomes low because current and resistance are inversely proportional. So going back to the last point, resistance increases with an increase in number of resistors. It means when we add another resistor in series, for example, you go back to the electric circuit, you put R4, it means the total resistance of the circuit is going to increase. And when the total resistance of the circuit increases, it means current is going to decrease. That point must be well understood, right? Remember, I said the only way you can change the amount of current it is when you have tempered with resistance or the power supply, right? Yes. So if we increase the resistance by adding a resistor in series, the total resistance of the circuit goes up and the total current decreases. So if the question can come, friends, and say, suppose we have added another resistor in series, which is R4. Briefly explain what happens to AT reading and give a reason for your answer. Right. How do you answer or how do you approach such a particular question? Definitely, when you increase a resistor or the number of resistors in a series circuit, the total resistance goes up. There is a mark there. Realizing that adding a resistor in series increases the total resistance, there is a mark for that, right? So, and when the total resistance goes up, what happens to current? Current decreases. Reason being, current and resistance are inversely proportional. So how do we calculate total effective um, resistance in a series circuit? This is very simple and straightforward. So RS, which is for series, is going to be R1 plus R2 plus R3. So RS is equal to our R1 is 5 plus our R2 is 3 plus our R3 is 4. So you need your calculator there. Then your answer becomes uh, We need mental work here. 5 plus 3, that's 8, plus 4, that's 12. And the unit for resistance is ohm. So that is going to be the total resistance, right? Or the equivalent resistance or the series resistance. It is going to be 12 ohm. So if you add another resistor, which is R4, you are just going to add that other resistance as well to 12. Then you still get your total resistance in a series circuit. So this is a series circuit, friends, and this is how it works. And that is very important for us to appreciate those 3 points. That current is the same, the current reading is the same everywhere. Potential difference divides evenly depending on their resistance or the resistor where the voltmeter is. But if you add up the voltmeter readings, they must give you back the total voltage. And then finally, resistance increases when you increase the number of resistors. And you must always remember that when resistance increases, current decreases because current and resistance, they are inversely proportional. Um, Thank you so much for watching. Thank you so much for following our presentation. You must also listen to the next presentation where I'm going to look at an